This week we are talking about the heating of the Earth's atmosphere, how it gets heated, and how that affects weather. So what we're going to go over today really just goes over the same questions that you should have looked at yesterday when you did the chapter. We did this question at the end of class yesterday, but 3 forms of radiation from the sun. Now, obviously, the sun puts out all of these types of radiation, everything from radio waves all the way up to X-rays and gamma rays. But in this question, what they're asking specifically is these 3 types of radiation that affect weather and heat the Earth. So it's the infrared, visible, and ultraviolet are the 3 types that it was looking for here. And if we put them in order, and we went over this yesterday, so I'll just do this real quickly, but infrared means below red, and then visible light is the red, orange, yellow, green, blue, indigo, violet. And then above violet is ultraviolet, which is higher energy than violet. And we finished up yesterday talking about the fact that UV light, and really everything above visible light, has more energy and can damage living cells. So which form of radiation from the sun has the longest wavelength? Then you're looking at the longest wavelength is the lower energy, and so that's those down here. Infrared has the longer wavelength. Ultraviolet is higher energy with a shorter wavelength. And that's going to be important as we talk about some of these other things that come up in these questions. So the 3 types of heat transfer, again, we did these yesterday. I'm not going to spend a lot of time on them, but we'll talk about them as how they heat the Earth and how they get transferred around. So conduction, convection, radiation, we've covered those many times, but you will need to know them. You will see them on the quiz. So what happens to most of the sunlight that reaches the Earth? And again, when you think about the whole solar system, we did that lab with the radiometers and the lamps. The Earth gets a pretty good amount of sunlight, not as much as the inner planets, but a lot more than the outer planets. What happens to most of the sunlight that actually reaches Earth? Yes? Some of it's filtered, but yeah, basically a lot of it doesn't reach the surface, right? Because what else happens to it? Glad you guys were working on your questions yesterday. Most of it's actually reflected and not absorbed. And we'll come back to why is the sky blue, because that's one of my favorite questions. But if we look at this straight out of the textbook, this answers all those questions that were right there. So about 50% of sunlight from the sun actually is absorbed by the Earth's surface. 25% is reflected by the clouds, dust, and gases in the air. And this is really interesting because we can see on days when it's cloudy, and we really notice that here in Colorado because we have so many very sunny days. If it's a little bit cloudy, the temperature is much lower, right? In the summer when there's been forest fires and volcanic eruptions would do the same thing, but that little bit of particulate and dust in the air reflects a lot more of the light, so the days are cooler. So 25% of the incoming light just normally is reflected by clouds, dust, and gases in the air. So if you have more dust and more gases, you get more of it reflected and less of it absorbed. About 20% absorbed by gases and particles in the atmosphere, 50% absorbed by the Earth's surface, 5% reflected back by the surface of the Earth. And then, as we talked about in our do now at the beginning, of this 50% that is absorbed by the Earth's surface, it heats the Earth's surface. Obviously, the darker parts heat more, and the lighter parts heat less. In the winter, when everything's covered with snow, you get less of that heating. And then that is radiated back into the atmosphere or heats the air directly when it's touching that. So of all of the energy from the sun, about 50% of it is absorbed and about 50% is reflected back by various things. Got it? And what we're going to find out tomorrow as we do our lab is just the difference in heating and cooling of water, air, and sand. When we go back to here, why is the sky blue? Nobody? The best question in the world, why is the sky blue? I'm so going to put that on the unit test. Yes. It is not because of the reflection from the ocean, but that's a good guess. Yes. Kind of. Kind of. He said reflection of the radiation off the atmosphere. Let's go back here. It's because of the wavelengths of light that are coming in. The blue wavelength. So some of them are reflected. The ones that are reflected to your eyes are the ones you see. So because of the oxygen and nitrogen in the atmosphere, because of the chemical makeup of the atmosphere, it affects which one of these wavelengths we see the most of. And so we see in our atmosphere, we see the blue, and so these higher wavelengths are the ones you see. So then why are the sunsets red? What's different about the light that might be getting to us in a sunset? So you get more scattering. Yes. And it's kind of weird to think about, but so here you are on the Earth. And during most of the day, the sun's right above you. So it's coming straight down and you get the blue sky because these other wavelengths, the longer wavelengths, lower energy ones, are not getting to your eyes. So later in the day, sunset or sunrise, the sun is down here. Let's see if we can turn it this way. And it's actually going through not just this amount of atmosphere, but it's going through more atmosphere than that, because if we could just pick this up and take this over here, like this, now it's coming through this much more atmosphere. So there's more air, more moisture. Where do you get really good, beautiful, super awesome sunsets? The mountains, or maybe over the ocean, or on cloudy days, or actually through the pollution. You could actually, the pollution, the brown cloud over Denver, actually is a lot of particulates in the air, but it can make really pretty sunsets. On the days when you've got forest fires and that, those more particles will make pretty sunsets too. So it's scattering it more, and then you're seeing more of those, the red. So there's more scattering, more the lower wavelengths are reaching your eyes. And then when we go back to this picture, turns out on Mars, the sky is not blue. The sky is pinkish, orangish red all the time. So why might that be? What are some things you know about how the Martian atmosphere is different than ours? Yeah. Yes. So the ground is red, so there might be some of these same particles. The ground is red because the soil has iron and it's rusted, basically. So you've got that in there. What else do you know about the atmosphere? Yes? It's farther away from the sun, so it's getting less intense sunlight, sure. What's its atmosphere made of? Does it have the same things ours does? A little bit. Does it have as much oxygen? Could you breathe there? No, so it's got a very thin atmosphere. Is there water on Mars? Not a lot of liquid water, so it's very dusty. So the red dust, different gases in the atmosphere, not very much atmosphere, all of those things are going to affect it. So there we go. We've got all of that. I won't, on a quiz or test, I won't ask you the percentage of the incoming sunlight that's reflected by clouds, dust, and gases, but just knowing that about half of it's absorbed and the rest of it is reflected by these other things is good enough. Question? Yeah. Well, if there was no light, you wouldn't be able to see it, so everything would be black. Is that like if a tree fell in a forest and nobody was there to listen to it, what noise would it make? So it would still be the same colors, it's still made up of the same stuff, you just couldn't see it. Right? This is a trick question. Okay. So we talked about this already. The energy from the sun that's absorbed by the Earth's surface then heats the air. I'm going to talk about the greenhouse effect next. Question? Really? Well, you can wait a minute then. We'll come back to that one. These ones are all kind of in the wrong order here. Hang on, I have to find my greenhouse picture. Okay, hang on, let me find it, and we'll let you answer your question. Okay, so the greenhouse effect. The greenhouse effect is interesting because most people think of the greenhouse effect as a bad thing. But it turns out without the greenhouse effect, we wouldn't have life on Earth. Because the greenhouse effect traps some of the heat from the sun. And if it wasn't trapped, it would just be very cold. Remember when we talked about the different planets, Mercury and the Moon have no atmosphere whatsoever. So what is the temperature like on Mercury and the Moon? Very cold and very hot. So if there's no atmosphere whatsoever, it gets very, very cold and very, very hot. The Earth's atmosphere acts somewhat like a blanket to trap the heat, and it makes our temperatures here on Earth more moderate. It's not extremely hot. It's not extremely cold. Everywhere else we looked at that we studied in the solar system has much more extreme temperatures. And here on Earth, we have a relatively narrow set of temperatures. Mars, also with a thinner atmosphere, it doesn't get a huge amount. It gets much colder, but not a lot hotter. So everywhere else has that. And the example of this you can think of, that we can easily think of here in Colorado, a car in the winter, right? If the sun is shining, you get in your car and it's toasty warm because the sunlight goes in and is trapped in there, so it can go in through the windows but doesn't escape as easily. That's exactly what our atmosphere is doing. So it makes it manageable. Of course, the car in the summer gets up to, 120, 150 degrees Fahrenheit and is excessively hot. So in our atmosphere, we have what are called greenhouse gases, and if there's too many of them, then it will trap more heat. But if there's none at all, that's obviously a problem too. And so the greenhouse gases are, anybody know? Carbon dioxide is one of them. Carbon monoxide. Water vapor is actually a greenhouse gas. So there's a number of gases, but it's the fact that if there's too many of them, it does cause a little bit of an overall heating. And we'll get into that a little bit more when we talk about climate change. All right, next, that picture. What is temperature? And what is temperature is another one of those kind of strange questions. What is temperature literally when you talk about definition? Well, sure, how hot it is. We usually measure by the air around us. Right, so what's temperature? Temperature is the measure of heat energy. Heat is the energy of moving molecules. So if you look at, no? Excellent. No, hang on, but I want you to say that again because, hang on, I got lost again. average amount of energy of molecules, right? But this is important because remember when we were talking about the layers of the atmosphere the week before break? And we said the thermosphere is very hot because those molecules have a lot of energy because they're getting more energy from the sun. But if you were there, it would feel cold. So what does that tell you about how many molecules there are? There's not very many, right? So in the thermosphere, there are very few molecules, but each one of those has lots of energy. But since that energy is not really being transferred, it would feel cold. The temperature is low because if you look at the average amount of energy per volume, there's not very much. So this, and that's obviously a thermometer, a pail of water is the same temperature as a lake. Which one has more thermal energy? So which one has more energy? If they're the same temperature, but temperature is a measure of the average energy of the molecules. Which one has more molecules? The lake. So the lake has more heat energy because there's more molecules that there are. Right? Yeah, it wasn't a trick question. If it's if it's a 60-degree day at sea level and a 60-degree day on the top of a mountain, where do you get hotter? there's there's more heat energy in the atmosphere at sea level because there's more molecules. Okay. Confusing, but all right, question. Really? Allow. Okay. And then once again, we did this already. The three ways heat can be transferred: conduction, convection, radiation. How do they work together to heat the troposphere? We did that in the picture. Major way heat is transferred to the troposphere. So we did all these, right? Okay. Oh, what about this one? How can a hawk or eagle or turkey vulture just have its wings still? They're not flapping. How can it go upwards? Yes, it can. No, not momentum. Yes, thank you. Somebody said because hot air rises, you usually see them doing this earlier in the day because what's happening is the ground has heated up, the warm air is rising, and so you get the columns of warm air rising, and so they rise on those the heat currents, and they rise on that. And one thing we'll talk about next week is the local winds, the sea breeze and the land breeze. And you get this uneven heating of the Earth's surface, and that causes winds that might change from the morning to the evening. All right. I think that is most of what we need for today. Questions about any of that? So that's, again, that would be the thermal. We've got a heat transfer. Was land breeze and sea breeze in what you read about? No? We'll do land breeze and sea breeze later.